think we are live. Good. Okay, it's finally working. So today, it is March 29th, and it snowed last night. Crazy, huh? 3/29/21. So today, what I want to talk about more than anything is how to graph. We're going to be graphing exponential and log graphs, okay? So there's a few features we need. One is I'd like to have, let me write down a few things I want when you guys do these, okay? A few things I want. One is I want the correct shape, okay? I want the shape to be right. And I know on the exponential they have kind of like that J shape, does that make sense? Or an upside down shape. And even the logarithms do the same thing, but the shape quite often looks like a J, right? Exponential. Second thing I'd like is the correct y-intercept. I want the y-intercept. And the third thing is I'd like the asymptotes, okay? If we can get close to these three things, then I'll be happy, okay? So there's a couple of ways to do it. You can go straight to a calculator and go straight to the calculator and do it that way, but I can do it just by plugging in numbers. Like for instance, if I plug in 0, okay? So let's just plug in 0. So if I plug in 0, anything 0 power is 1. So I know there's a point at 0, 1, okay? Does that make sense? I plug in 0. In fact, you can try it on a calculator. So, okay, what is 2 to the 0 power? 2 to the 0 power is, it's 1, right? And then I can plug in 1. If I plug in 1, 1 to the 2 power is 2. And if I plug in 2, 2 squared is 4. And that's probably what I need. And we know the shape of this. We've done this before. So if I were to put those points down, let's see. And I put a point at 0, 1, 1, 2, and 2, 1, 2, 3, 4. And of course, we know the graph looks like this. Everybody agree with that? We did this. We've looked at these graphs before. Everybody agree with that? So that's the right shape. So if you were to graph this on a test, I'd need this shape, or the correct y-intercept, and there is an asymptote here. And the asymptote is right here at y equals 0. Okay? Thumbs up for that. Not too bad. And worst case, you go and you can do it, right? You can go to your y equals, and you can say, okay, gosh, Mr. Davies, what does 2 to the x power look like? And we can actually look at it, and there it is. Okay? There it is on my graphing calculator, right? So that makes it easy for us too. You can also put that on Desmos on your phone, but you won't need it, okay? Now, I want you to take a look at the inverse. Okay, now the inverse is just, if we flip these points around, we'll have a point at 1, 0, 2, 1, and 4, 2, right? If we want the inverse. Easiest way to get the inverse is I just flip the points around, right? And then I should be able to put a point at 1, 0, 2, 1. And we looked at this the other day too, right? If I have the opposite, and I have a horizontal asymptote, then its inverse would have a vertical asymptote, right? How's that? This is the log graph. I mean, if this is my exponential, then this is my log graph, so this should be a y equals log base 2 of x. And again, we talked about that on Friday, right? Domain of this, of the exponential, the domain of the exponential is x equals all real numbers of the exponential, the blue one, okay? Right? But the range is y is greater than 0, okay? It starts and goes up, right? It starts and goes up, never touches 0, but goes up. But now we're going to find with the log graph, its inverse is just the opposite. So the domain, put this one in red, the domain of our log graph, our red graph, is there's no graph over here, right? There's no graph over here at all. The graph starts, this red graph starts here and goes this way, so the domain is x is greater than 0. But the range goes forever down and forever up is, the range is going to be, y is going to be, on this one, equal to all real numbers. So, and I'm going to say, everybody listening? Check this out. The domain of this one becomes the range of that, and the range of this one becomes the domain of that, which actually makes sense because we switched x and y's. Doesn't that make sense? If you switch x and y's, that means all the domain switches to the range, and all the range switches to the domain. Okay? All right. Number 2. So number 2 is very similar. One of the things we can do is we can check it out on a calculator. I know that for sure. I can go y equals clear, and my calculator will do a e to the x power. It will, but if you can't figure that out, I'll show you another way to do it. So it's pretty similar. If you graph it, pretty darn similar to what we just had. Okay, what's the difference? The only difference is it's a little bit steeper. Okay, so if I wanted a couple of points, I could. Okay, I know for sure if I plug in 0, I do get 1 because anything to the 0 power is 1. If I plug in 1, I'll get e. Now, plug in 1, e is about a 2.7, right? We've said e is about 2.71. If I plug in 2, well, I don't know. Let's see. What is e to the 2 power? Well, that's what calculators will be for. Quit. Clear. Quit. So what is e to the 2 power? I don't know. About 7.4. About 7.4, okay? So if I were to put down these values, I'm going to go a 2 and a 7.4. 1, 2, 5, 6, 7.4. Maybe there, and a 1, and a 2.7. Right about there. There, okay. So it looks almost the same, right? Except for it's just a little bit steeper. I don't know if you can see that it's steeper because the base is a little bit bigger, right? All right, and asymptotes, I would put here. Got it, okay. Am I doing okay? As long as you guys can use the calculator, it gets pretty easy, doesn't it? Okay, now, 3. What does 2 to the negative x look like? Well, let's just take a look at it. Why not, right? Clear. If I go 2 to the negative x power, let's see what that looks like on my calculator. I'll graph that. So that one goes down. That one's like just the opposite, right? It goes through, I know that it has to go through, if I plug in 0, it does go through 1, because anything to the 0 power is 1. If I plug in 1, I get 1/2. I do. If I plug in 1, I get 1/2. So this graph is just kind of the opposite of the other. It really is. So this graph is going to kind of know what it looks like. Point at 0, 1. I'm going to have a 1 and 1/2. But then I should have a -1 and 2, a -2 and 4. And this graph looks like this. Okay. One of the features you can get from these calculators, I'll have everybody watch in a second, okay? I don't know if you guys are using my calculators or not, but let me show you a feature on these calculators. Okay. So, see this button trace? You guys see the button that says trace? Check it out. So if I go to trace, it gives me points, doesn't it? There's a point. There's points, gives me lots of points, right? If I want specific points, let's say I want 2, gives me a value. If I want -1, gives me a value. Give -2. So I'm just using my trace button. Trace button is really slick because it gives you all those points. All right. Put in my asymptote. There it is. I have my asymptote. How am I doing? Thumbs up okay? The calculator really makes it easier, okay? Technology. Turn the page. Yes, no? All right, here we go. So a log graph. So how do you do a log graph? Well, this is log. So y equals a log base 10 of x, okay? Now we could graph it. Why not? The first thing I would think, if I were a kid, I'd say, hey, well, gosh, if my calculator could do it for me, right? Why not try it, right? So I did log of x, okay? Let's see what it looks like. Kind of know what it looks like. Graph That doesn't show a lot of it, but I know a couple of features, okay? It has to go through at 0, 1. In fact, we know that because we saw log graph over here. Went through the point 1, 0, right? I think I said that backwards. So it has to go through the point 1, 0. So I know I'm going to put a point there. And because it's base 10, it's also going to go through 10, 1. And I'll show you on that. I can also use my trace button on that one. Trace. I'm going to go to 10. I didn't like that. Clear. Let me go back to my graph. Trace. 10. Probably have to make a bigger window. Okay, quit. Window. Yeah, I gotta have a bigger window so I can see it. Get 12. Good graph. There we go. Alright. Now I'm going to show you this. I can plug in 10. 10. Oh, clear. Trace. 10. There we go. I knew it was 1. So I can go all the way to 10, 1 because of base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, okay? And then I know the graph looks like this. It just goes like this, okay? There it is. Not a very good graph because I'm not much of an artist, okay? I want the right shape, right? I got the right shape. And I want my asymptote. My asymptote is that one. My asymptote is a vertical asymptote, okay? So I want an asymptote, I want the right shape, and I kind of like to have these 2 points, okay? All right, now, number 5. We've done 5. In fact, it's exactly this graph right here. It is. We did this graph. So let's take a look at it again. So I do know this, okay? Any log graph, it's got to go through the point 1, 0. Okay, it has to go through the point 1, 0, so I'm going to put that down there. And since it's base 2, it's also going to be at 2, 1. It's base 2, so it's also going to have a 4, 2. 1, 2, 3, 4, 2. It's also going to have a 8, 3 because base 2. And I'm going to show you this. 1, 2, 3, 5, 6, 7, 8, 3. Now again, one of the things I could do, of course I have a fancy calculator, don't I? Right? Mr. Davies has a fancy calculator. So the trick for you guys, now watch this carefully. I'll go through this slowly, okay? You guys have a good calculator? Do you have one of the nice ones? If you have a nice calculator, then watch. We're going to go y equals, clear that. Okay, y equals. Don't get one of the old ones. So it's got to be one of the new ones that are the orange ones, okay? The old calculators will not do this, okay? I'll wait for Edie to get it. Edie, did you find one that works, a new one? I've got batteries right here. Here, I'll give you new batteries, okay? Yeah, I'm going to use those calculators. So, what's that? The white button's right up top. Yeah, good question. Okay. So let's see if everybody can do this, okay? We're going to go y equals, okay? Thumbs up. Everybody have it? Okay, I'll wait for Edie. So the good calculators will actually do this. We'll go log, but we got to go base. So we got to go math. Got to push. So we're going to push the math button. Okay, to do this, you got to go find your math button. Okay. I'm going to go math, and I'm going to go down, 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 until I find that. Okay, log base. So I'm going to go hit them all. Then I'm going to go find log base. Okay. Edie, how am I doing? Am I going too fast? Probably. Okay, so Edie, I went y equals. Then I went to the math. And I went all the way down to log base. Now, what I'm going to do is, that's not, that looks weird. It shouldn't look like that. Y equals, shouldn't do that. Well, log base, maybe it won't graph these. I thought it would graph these. Okay, hold on for a second. While I'm in the middle of doing this, math, log base. Oh, see, it'll do it there. Huh, well, bummer, it won't graph it.
Mine's doing that.
Did you get yours to work?
Yeah.
Can I see your calculator, please? Let me see what you got, because mine won't do it. I don't know why mine won't do it. Awesome, okay. So we'll go log base 2, and we'll go over to the X button. Thanks, Antonio. And we should be able to graph it. Oh, you got a scatter plot on yours. That's right, I'm going to change your window. And I'm going to get rid of your scatter plot. Scatter plot on, off, window. I'm going to go -1 to 10. I'm going to go -5 to 5. Graph. There it is. Thanks, Antonio.
Once you enter your algorithm, how do you enter it? Oh, do you just the graph?
Yeah, then you push the graph button. I don't know why my calculator wouldn't do it, but yours would. Did you guys get that to work?
Mine just shows graph.
Okay, I'm gonna come back and help everybody in a second, okay? So it looks something like this. So when you look at today's homework, you can use the calculators, okay? Homework today, Ellie, I promise I'm coming to help you next, okay? It's gonna be page, I wanna get this recording done, 152, and I want you to do all the graphs, 1 to 6, all. There's really no good extra credit problem, so, and I'll stop my recording.